Experiment number 4, which is about interfacing a LDR sensor with Raspberry Pi and display the message whether the room is dark or room is bright. And another experiment is to interface a soil moisture sensor with Raspberry Pi and check the wetness of the soil, or whether it is wet or dry. And first program which I'll be explaining is about how to connect a LDR sensor with Raspberry Pi and find whether the room is bright or whether the room is dark. Now here, this LDR sensor, which you have it on the screen, so it is made up of this material which we are using here, which sits on this, which is deposited on this glass substrate. It's a glass substrate, and this material is cadmium sulfide. It's a semiconductor material whose resistance vary based on the intensity of the light which falls on this. So the concept is pretty much simple. This resistance, what you collect it here or what you record here, will be collected by the microcontroller, and we take the decision. So more the intensity falling on this device, the resistance of the resistance collected across this LED will be lower. So very low the brightness or very low the light, the resistance will be higher. So this resistance across the terminal is collected to the comparator. So comparator takes this voltage drop, which is proportional to the resistance measure across, and there is a potentiometer which again is used alongside with this, and these two voltages which you get through the pins of a comparator are compared, and we take an appropriate decision. For example, let's say that this is the circuit which we are having here. So here we have LDR sensor here, and you have a potentiometer here. So first, let's say that the room is bright, in which case you get a very low resistance. You can consider resistance in terms of ohms, and corresponding to that you get this is applying voltage division formula. You have the formula for finding the voltage which you get through pin number 2 as V out divided by R1, which is plus R3, and in the numerator you have resistance across this terminal, which is R3. So by taking R3 as very small value and R1 is already given, so you can estimate this voltage will be quite small. So when this voltage is small, and if we set this voltage with the help of pot, let's say that we define this voltage as this voltage from this end to this end, I'll take it as 5k, or else if I assume the resistance to be 5k and the other resistance to be 5k, then the voltage which I'll be getting will be approximately divided equally, so which means 2.5 voltage I get here and 2.5 volt I get here. So this voltage at pin number 3, when you get here very small voltage, this particular voltage will be quite larger than that. So when pin number 3 voltage is greater than pin number 2 voltage, this device will be triggered to high. So most of the systems, this LM393 comparator, it comes with an open collector output, which means any output which you get here might be inverted out, and that logic you're gonna get, which means if this output is 1, using open collector mode, that output becomes a 0. And this is the thing which we receive in our microcontroller, and we take the appropriate decision. This is the logic. Let's look at the program. Here you've got the program here, which says that you need to interface the connection between the LDR module and the Raspberry Pi. So you have a Raspberry Pi module, and you have a LDR module. So this LDR module will be having 3 terminals. So LDR it's used as an input port. So LDR has VCC, it has ground, and it has digital output. So connect VCC of LDR to VCC of Raspberry Pi, ground with ground. So make sure that you are using 3.3 volt VCC. Use 3.3 volt VCC for LDR, and the last pin, digital output, goes to, let's say, pin number 12, which is also GPIO 18. So this is the physical connection which needs to be done, and we find what's the value of this pin which we are receiving through pin number 12 or GPIO 18. The program is written according to that. So here this should be modified to pin number, if it's a BCM mode, this is 11 implies it's better you modify this to 18 so that we can connect pin number 12. So the program is meant for setting the mode. Here we use GPIO mode. This is for ignoring the warnings. This line is for defining the direction of the pin. We are using a sensor, so it will be acting as an input port, and here we do this always. So check the state of the pin which is connected to pin number let's say 12, physical pin number. So suppose if I am receiving state 1, then it means the room is bright. So state 1 implies through the digital output pin you are getting value 1, implies if I am using a open collector output logic, the output at pin number the output which I'll be getting at pin number 1 is negated. So here if I get here 1 when the voltage across 3, when plus 3 voltage is greater than 2 voltage, then I get 1. So using collector mode, open collector mode, that is negated, so you get 0. So if you get the 0, then you say that here the room is dark, otherwise we say that the room is bright. That's the logic happening. Similarly, if I'm using soil moisture sensor, the way soil moisture sensor works is here you have this device, soil moisture sensor. So one end of this probe is connected to the comparator, and another end of this comparator is connected to Raspberry Pi. So this is the connection. So you've got again 3 pins here, 4 pins, analog output, digital output, VCC and ground. So this system works with 5 volt. So the working, as you dip this device, as you dip this FC28 coil onto the water, more you deeply you dip it, so the content or the water level content will be increased, and this is a conductor which will increase its current as more water content is available or deposited on this coil. So more the water level content, current will be more, and resistance will be lower, and this resistance is acquired, and its equivalent voltage drop is collected at pin number 2, which happens to be this. So here LDR will be replaced by soil moisture, so you're gonna get a voltage. The same voltage is compared with the voltage set using this potentiometer. So pin number 3 and pin number 2 voltages are compared, and if I get pin number 3 voltage higher than that of pin number 2 voltage, then you get 1, but using open collector mode we negate input and we make it as 0. So when you receive 0, it means that here in this case soil is dry, otherwise we say that the soil is wet. So the program for both the devices are same, only the decisions which we need to take will be different.